square upon this value. Can I do it or not? Right? Or okay, find it. Can I write concentration of H plus equal to root of Ka into C? Right. Ka equal to C alpha square upon 1 minus alpha. Okay. 1 minus alpha is approximately equal to 1. Negligible, no? So it will be approximately equal to 1. That means what I will write? Ka equal to C alpha square or alpha equal to root of Ka upon C. What is concentration of H plus? C alpha only, na? Respond. So what is H plus? What is H plus? C alpha. C already we know into alpha. Instead of alpha, if I write root of Ka upon C, C goes to numerator. Goes under the root. C square. C gets cancelled. So root of Ka into C. So root of what is Ka value? 10 power minus 5 into C value. 10 power minus 1. What is this value? 10 power minus 3. If I write 10 power minus 3 here, log 1. Log 1 is, means this total term becomes E naught value for hydrogen electrode is, means total E value is. Say something, sir. Yes or no? Correct? Any questions in it? Say something. Any questions in it? So answer must be, check the answer what they gave. What they gave? Fourth option only. Next question. Question number 14 over. 15 okay, 16 okay, 17 to some extent okay, 18. 54% people has left that question. Question number 18. 18 plus 25? 23, yeah? 43. This question most of people left. Delta S naught for the reaction happening inside a cell with standard electrode potential E naught is. They want delta. We derived this also, man. We derived it. How we derived? Delta G naught equal to minus NF E naught. Another one. Delta G naught equal to delta H naught minus T delta S naught. And we have seen one more equation also. dG equal to VdP minus SdT. Correct? Now, if temperature is constant, what you get? dt becomes 0. If a pressure is constant, dp becomes 0. Then vdp term becomes 0. So dg upon dt at constant pressure can be written as minus s. Means minus delta s is equal to d delta g upon dt at constant p. Can I write it? So minus delta s naught is equal to, instead of delta G naught, what I can write? Minus NFE. So minus NF d E naught upon dt at constant P. Can I write it? Say something. Now I am substituting this term here. So what I am writing? Minus NF E naught equal to delta H naught. Oh, what you want? You want delta H naught value or delta S naught value? The delta S naught. Oh, we need to find delta S naught equation. Huh? Over. No need to substitute. Array, no need to substitute now. We want delta S naught equation only. Right? So what do you write? So delta S naught equal to what I will write? Minus NF E naught. Minus or plus or? And T delta S naught equal to. Bring this to the side, man. Minus NF E naught minus delta H naught. Minus cancel. So plus NF E naught plus delta H naught. Correct? Huh? Divide the total equation with T. Nothing wrong. Take NF common. NF common or NFT common. Can I take NFT common? NF upon T common. Right. I am taking NF upon T common. What is left? E naught plus delta H naught upon NF, right? Did I say something? So this is delta S naught equation. So which is correct? First option, NF upon T common means E naught plus delta H on NF. So first option. Instead of del S, if I substitute this term also. Instead of del S, if I substitute this term also, what do you get? NF T naught upon dt at constant P is equal to, I am cancelling that NF also. So what do you get then? 1 upon T into E naught or a negative, there is no minus sign. Huh? E naught plus delta H naught upon NF. You can get this equation also, right? But they have asked only up to this. No need to substitute this. Means no need to do this also. Clear? Next question. So question number 18, okay. Question number 19, 20, 21. Question number 21, 50% people left. Right? 21 plus 25. 46. So question number 46 we need to see. Question number 46. Question number 46. Solve this question. ppm level of F minus in a 500 gram sample of toothpaste contains 0.2 grams. F minus is X. Then the value of root X is what they are saying. 500 grams sample you have taken. In it, 0.2 grams is F minus. Then we need to find ppm, parts per million. What is ppm formula? What is ppm? The weight of substance per million parts of the substance, man. Weight of substance per million parts. Means I am taking this as if it is 500 parts. If it is 500 parts, how many parts is this? 0.2. If it is million parts, then what is this? X. That X is nothing but ppm, na? I say something. Now what is ppm equal to? 0.2 divided by 500 into 10 power 6. Right? So I am writing this term as 2 into 10 power 5. Is there anything wrong? Nothing wrong now? Now, this 10 power 5 I am writing 1000 into 10 square. Is there anything wrong? So I am writing this as 1000 into 10 square. Is there anything wrong? Nothing wrong now? 500 how many times? So total value 4 into 10 square. This is ppm value. Then what is root x? 20. Check the answer. What they gave? 20. Next question. Question number 21 over. 22, okay. 23. 72% people has not given question number 23, sir. 72% people left. Throughout country, 76% people has not given that question. Question number 23. 23 plus 25? 48. So question number 48, I need to check. Question number 48. This question, most of them not given. Solve this question. Temperature coefficient of this cell is this. Entropy change accompanying the cell is. Temperature coefficient means dE by dt. Right? Temperature coefficient, man. Temperature coefficient means dE upon dt. This is called temperature coefficient. Right? Just now we have derived it. Delta S is equal to, oh, not given. I removed it, I think. See this. dG equal to VdP minus SdT. If a pressure is constant, what I will write? dG equal to minus SdT. So I am writing dG by dt at constant pressure is equal to minus S. So d delta G upon dt at constant pressure is equal to minus delta S. Instead of delta G, I am writing minus NFE. So what you will write? Minus NF dE by dt at constant P is equal to minus delta S. Correct, sir? Minus and minus gone. So what you got? Delta S equal to NF dE by dt. They gave dE by dt value. dE by dt value, what they gave? 0.005 volt per Kelvin. Then what they are asking? Entropy change accompanying in the cell reaction. So what is delta S now? Multiply that with NF. Correct? What is N? Iron is converting from 0 to +2. Response, sir. So what is N value? 2. You can take it as 2 or not. Or here it is +1 to 0. Either I can take it as 2 or I have to take it as 1. If I take it as 1, accordingly I need to do it. In any redox reaction, number of electrons gained and lost must be equal. So I am taking it as 2. Here I am taking 2 means here also I will take 2. 2 moles. Clear? So I am taking N value as 2 into 96,500 into 0.05. Can I write as 5 into 10 power minus 3, 0.005. Can I write like that? So 5 into 2, 10. 10 and 10 power minus 3. 10 power minus 2 into this. So what is that value? Check the answer. 965. Next question. So question number 24, 57% people left. And question number 25, 65% people left. So I am taking these two questions, both. Right? Means question number 49, 50. Correct? Huh? So question number 49, 50. Oh, both questions, huh? So I am taking both questions. Question number 49. If 6 moles of electrons are passed through acidified water, moles of gas discharged is X, then 2X is. You are transferring 6 moles of electrons through acidified water. So what happens at cathode? What happens, sir, at cathode? 2H plus gain 2 electrons to form H2. At anode, what is present at anode? Water only, H2O. So H2O gives rise to form 2H plus plus 2 electrons plus half O2. Correct, sir? So if I pass 2 electrons, one H2 is liberated at cathode, half O2 liberated at anode. So for 2 electrons, totally how many? 1.5 means 3 by 2. So for 2 electrons, it is 3 by 2. For 2 electrons, or if 2 Faraday, then it is 3 by 2 moles. Correct, sir? If it is 6 moles of electrons, 6 Faraday, how much? Correct? So what is value? So x equal to 9 by 2. Therefore, 2x is. So answer is 9. Next question. Equal volumes of 0.01 molar acetic acid, 0.01 molar NaOH are mixed together. If the molar conductivity of the mixture is x, then the value of x by 16, the value of x by 16 is conductivity of sodium acetate in the solution is in the cell is 6.4 into 10 power minus 4. Both given as 0.01, 0.01. Conductivity kappa is given, right? Molar conductivity of the mixture is x. Then what is x by 16? So how to find molar conductivity? Lambda equal to kappa into 1000 upon molarity. Respond, sir. Now, what is kappa value? 6.4 into 10 power minus 4 into 1000 upon, what is the molarity value? What is the molarity value? No. Array, equal volumes. If it is 1 liter, if it is 1 liter, the moment I mix, total volume becomes. If a total volume becomes 2 liters, what happens to its concentration? Half. Its concentration also become half. Means the salt concentration becomes 0.01 by 2. Correct, sir? Respond. Correct. So 0.01 by 2 means can I write as 0.005? So I am writing it as 5 into 10 power minus 3. 0.005. 5 into 10 power minus 3. Any questions? So what is this value? Minus 3 and here it is gone. So minus 1. Minus 1 and 1 0 I removed. So 5 20s are. Response sir. So 64 into 2. Okay, I will write that as 64 into 2 only. Right? 64 into 2 is x value. Then what is x by 16? This divided by 16. So answer is 8. Check the answer. 4. Right? In this way, you need to do analysis of your paper. Otherwise, everything becomes wasted. So whenever you are preparing, you need to prepare more seriously. I will close this. Out of 208 students, 150 students appeared. What about remaining students, man? 56 students, right? Means I will consider our branch strength as 152 only. For sure, I will disturb them like anything. I will make that 56 people either attend classes regularly, give the test regularly, or they will run away. Mostly by next UT, I will make this number to become 150 only. I will for sure I will torture them. I will make them to leave. Why I have to take that headache? This is Pan India versus our branch result. Last year also I told. What I told? What I told? If our branch result comes less than Pan India, what I told? Say something, man. Last year student. Means our branch is waste. Right? You need to work on max. Last year you used to get greater marks in max. What happened? This paper was tough. Say something. Then why you are not doing well? Overall 41.65, 41.7. Your all India average and a branch average is maintained. And 50 people has not given. Highest mark, who is this fellow? Harish Kumar, yes, who is this? Harish Kumar, yes. Harish Kumar, yes, who is this man? Only I think he attends only online. Harish Kumar, not there. Second, Sri Vishandi. On that day she came, later she stopped coming. Vishandi, not there. Aishwarya belongs to weekend. Velavan. I will select your batch only. Now selected only your batch. Aditya K. Who is Aditya K? Where is he? Huh? Aditya, not there. Pranav Lakshman. Jagadish VR. Pranav Lakshman, Jagadish VR. Mithun. Mithun. How many marks, man? 73, 68. Chemistry only less mark. 68, 73. 73, 68, 73. Akhilesh. Same. 72, 64, 77. Chemistry only less mark. Sai Nitin Pandey. Sai Nitin. 86, 58, 66. Again chemistry less mark. Sri Nikesh, huh? Sri Nikesh. Who? Online. Now I will see your batch average. Means your batch average chemistry, obviously it shows chemistry marks are low. 38.96, 35.47, 39, 38.56. Less than national average, means waste. 45.17, 44.37, 41.04, 39.47. Means all subjects waste only, man. All are waste only. In every subject you got lower than national average. Means 23 people in your class, no, 23 people are above 95 percentage out of 58. Right? Leave it. So come to next topic then. Yes, sir. What we are discussing in last class? What we are discussing? Factors affecting. That already we have done, man. Factors affecting rate. Theory only, na? Just I will show that and I will quickly complete it. And I will go to next part. This is factors affecting rate. What is the first one? Concentration. If I increase concentration of reactants, the rate also increases. As the time proceeds, what happens to rate? As the time proceeds, concentration of reactant decreases. Therefore, rate also. So concentration of reaction at a time t is written as RT equal to M is stoichiometric coefficient. So mk into concentration of A. As time proceeds, what happens to concentration of A? Decreases. Then rate also decreases. Initial rate I am writing it as R0. Among R0 and RT, which is higher value? So that's what I wrote. R0 is greater than RT. Same thing when you are studying in nuclear chemistry. Here we wrote as rate. There we call it as activity. So activity is nothing but minus dN by dt. Then instead of K, we will write lambda. Lambda is nothing but disintegration constant. Right? So units of activity is Curie, or Rutherford, or Becquerel. Curie means 3.7 into 10 power 10 disintegrations per second. Rutherford 10 power 6 disintegration per second. Becquerel 1 disintegration per second. Any questions in this regarding concentration term? Regarding concentration, do you have any questions? Next parameter, nature of reactants and products. Right? Generally, solids will react less readily than liquids than gases. In case of solids also, if a surface area increases, if I make them into powder, then rate of reaction enhances. As surface area increases, rate of reaction enhances. And one more thing, if a complex molecules are involved, then rate will be generally slow. If a complex molecules are involved, generally rate of reaction will be slow. Right? If there is less number of bond rearrangements, then rate is more. If there are more number of bond rearrangements, then rate will be low. Any questions in this? For example, we have taken this one. Here only 5 moles of iron. Here C2O4 2 minus. Among MnO4 and acidic medium, these two are same. Here I am using KMnO4 as oxidizing agent in acidic medium. Here also KMnO4 in acidic medium. So both are allowed to react with same reagent. But here iron is in +2 state. Here C2O4 2 minus, oxalate ion. Here there are some bonds. Here only ion. Right? Here I need to break bonds, right? In first case, no need to break any bond. Ionic reaction. In second case, I need to break bonds. Therefore, obviously rate decreases. If this is R1, this is R2. R1 is greater than R2. Why in second case rate is less? Because of more bonds I need to involve during rate of the reaction. Clear? For the reaction. That's why slow it will be. Right? So the reaction which more bonds has to break or rearrange, then rate will be less. Any questions in it? Next, exposure to light. Any reactions which is sensitive to light are called as photosensitive reactions. Right? So some molecules absorb light energy and transfer that energy to other reactant molecules and make the reaction to occur. Right? Such molecules are called as photosensitizers. Right? Another example, chlorophyll acts as photosensitizer in photosynthesis of plants. Chlorophyll will absorb light and it will transfer that energy to carbon dioxide and water molecules to produce carbohydrates. Clear? Any questions in it? Next. This also we have seen just now. Now temperature. If I increase temperature, molecules move more randomly. Molecules will make more collisions and they will convert into products more readily. For every 10 degrees centigrade rise in temperature, rate of reaction increases by 2 to 3 times. We call that as mu, or we call it as temperature coefficient of a reaction. Right? So we wrote that as KT2 by KT1 equal to mu power T2 minus T1 by 10. And this is change in temperature. If I divide with 10, how many tenths temperature is changing? That I will get. Mu power that value. Clear? Mu value generally ranges between 2 and 3. So generally we will take it as 2 for easy calculation. Any questions in that? Next, energy of activation. Where we have seen this energy of activation? In collision theory, we have seen, man, energy of activation. If you plot a graph between energy versus reaction coordinates, if we plot a graph between potential energy versus reaction coordinates. If I got a graph in this manner, what we call this as activated complex state. This is energy of reactants. This is energy of products. Now what we call this as? We call this as energy of activation. Right? This total energy is called from here to here. This total energy is called threshold energy. This is called threshold energy. Threshold energy is called minimum energy required for a reaction to occur. Right? To reach threshold energy, this is the energy provided by us. We call that as energy of activation. If this energy of activation is more, then reaction occurs readily or reaction doesn't occur. Right? So as energy of activation increases, rate of reaction decreases. So that's the statement we have taken there. As energy of activation increases, rate of reaction decreases. Now, catalyst. What generally catalysts do? What generally catalysts do? For example, I'm taking same reaction. I have taken this, right? This is the activated complex. If I add a catalyst, this is the energy parameter. This is in presence of catalyst. This is in absence of catalyst. Now tell me what catalyst has done. This is in presence of catalyst, that is in absence of catalyst. What catalyst has done? It changed the path, right? It is changing energy of activation. Correct or not? Earlier energy of activation is this. This is the energy of activation. If energy of activation decreases, what happens to rate? Increases. So catalyst will alter the reaction path. If it alters the reaction path and decreases energy of activation, then rate of reaction increases. Right? If I add inhibitor or catalytic poison, what it will do? It will increase energy of activation. Catalyst decreases and increases rate. Catalytic poison or inhibitor increases energy of activation and decreases the rate. Clear? Any questions in it? So see that statement. What they have given? Catalyst enhances the rate of reaction by changing the reaction path. That is by decreasing energy of activation. Inhibitor or catalytic poison decreases rate of reaction. Means it increases energy of activation. Promoter enhances the activity of catalyst. The amount of catalyst remains unchanged during a reaction. Right? Any questions in that? So we are done with factors affecting rate of a reaction. Right? These things are already over, man, in the previous class. During alpha emission, beta emission, these things are already over. Response, sir. Right? Now, before going further, let me discuss few more points. If a reaction is reversible, moves in forward as well as backward, then what is this one? Energy of activation for backward. This is energy of activation for forward. Then what about this gap? Delta H of reaction. We call that as delta H of reaction. Now I am writing delta H of reaction as energy of activation for forward minus energy of activation for backward. Now, among these two, which is higher value? Then this value becomes positive. Means delta H of reaction became greater than 0. Therefore, this reaction is endothermic reaction. Are you able to understand? Right? For example, if a reaction is given in this way. In this way. This is energy of activation for forward. This becomes energy of activation for backward. Now this becomes delta H of reaction. Now backward is greater than forward. Means delta H became negative. Therefore, this reaction is exothermic. Response, sir? Any questions in it? No. I am plotting one more graph. If I plot a graph between fraction of molecules versus energy. I'm plotting a graph between fraction of molecules or fraction of reactant molecules versus respect to energy, maybe kinetic energy of molecules. Right? This type of graph already we studied in states of matter. Fraction of molecules versus velocity graph. What do you get? Bell-shaped curve. And in this room, gas molecules are present. Do all gas molecules will have same energy? So number of gas molecules having higher energy will be less. Number of gas molecules having lower energy is also less. Most of the molecules will have most probable energy. Correct? So you will get a bell-shaped curve. Unsymmetrical bell-shaped curve. Right? So these are the molecules having energy greater than certain value. If I consider this is the energy, minimum energy required for a reaction to occur, molecules having energy greater than that only will convert into product. What I told you. Only molecules, if they reach threshold energy, then only they can convert into products. Right? Means this is the fraction of molecules having energy greater than this. Only they will convert into product. So this area represents fraction of molecules having energy having EA. Why I am writing having EA? This is the EA is the energy required for reactant to reach this state, na? Right? These are the fraction of molecules having EA value, right? Or greater than EA, having energy greater than EA. Mathematically, I can write it as N EA upon capital N, where capital N represents total number of molecules. N represents number of molecules having energy greater than that. This becomes, or this can be written as E power minus EA by RT. Fraction of molecules having energy greater than energy of activation, or fraction of molecules which can convert into products can be written as E power minus EA by RT. Now, if it is at a temperature T1, if I increase temperature, what happens? If this is at a temperature T1, let me take this graph. I am taking this graph. If this happens at a temperature T1, on increasing temperature, what happens? Do total number of molecules change? But their energies will change, right? Means area under the curve doesn't change, but peak moves to higher values. So the graph will be something like this. This is at a temperature T2. T2 is greater than T1. Now what happens to fraction of molecules which can convert into products? Enhanced. Right? That means on increasing temperature, what happens to rate of reaction? Just now we have seen on increasing temperature, rate of reaction increases because number of molecules having energy greater than this increased. That only we wrote in a energy mathematical form also. For every 10 degrees centigrade rise in temperature, rate of reaction increases by mu times. Correct? For every 10 degrees centigrade rise in temperature, rate of reaction increases by mu times, where mu value ranges between 2 to 3. We wrote that as K at T2 upon K at T1 is equal to mu power T2 minus T1 upon 10. Sponsor, we have already seen this, right? No. According to Arrhenius, the rate constant K can be written as A into e power minus EA by RT. Already we know what is this e power minus EA by RT. What is this? Fraction of molecules attained that energy, right? Whereas A is called Arrhenius constant, or we call it as pre-exponential constant. Right? Now see this. This is fraction, man. If this fraction value is 1, right, then K becomes A. This fraction value became 1 means what is the meaning of it? This fraction became 1 means all molecules convert into product. Correct or not? Response, sir. All molecules are converting into product means what A represents? All molecules are converting to products means A become equal to K or K become equal to A. Means that is the maximum value of K possible. No? All molecules are converting into products means that is the maximum rate possible or maximum rate constant possible. Clear? So now tell me what is A represents? A represents every collision converts into product. A represents every collision converts into products. Pre-exponential factor, that is a factor which represents every collision leads to product formation. Or can I say, when temperature T tends to infinite, what happens to this one? What is this EA by RT now? Anything power 0 means K becomes equal to. Correct or not? So when T tends to infinite, therefore K becomes equal to A. T is infinite means what I told you, as temperature increases, rate. When T tends to infinite means rate becomes maximum. Correct or not? That is the maximum possible rate. That is maximum possible rate means that is the maximum possible K. Right? So what A represents? A represents maximum value possible for K. Clear? Any questions in it? According to Arrhenius, all collisions, molecules when they make collision, all collisions will not lead to product formation. If molecules convert into product means first they make collision in a proper direction and also with proper energy. Then only they will convert into products. We call this as collision theory. So according to collision theory, reactant molecules collide with each other with sufficient energy in proper direction, then only they will convert into products. We call such collisions as fruitful collisions or effective collisions. But all collisions are not effective. Is it clear? So according to collision theory, all collisions are not effective. Right? Effective collisions means what is the meaning of effective collisions? Collisions with sufficient energy. Can I call that sufficient energy as threshold energy? Respond. Collisions with sufficient energy means a threshold energy. And proper orientation. This proper orientation is indicated by a factor called P. We also call it as steric factor. These two are responsible for product formation. So generally this P factor, this is generally less than 1. This is generally less than 1, right? So collisions which are in proper direction with sufficient energy only converts into products. If you want to compare these two ideas, we can also write this K as P into Z into e power minus EA by RT. What is this P? Steric factor. What is Z? Collision frequency. This Z is nothing but collision frequency. Right? Where we discussed about this collision frequency. Gas state chapter we discussed, man. Mean free path lambda. What is mean free path? Mean free path. What do you mean by mean free path? Distance traveled by molecule between two successive collisions. If after making one collision here, to make another collision, how much distance it has to travel? That is called mean free path. So that mean free path lambda can be written as 1 upon root 2 pi sigma square NV. Respond. Instead of NV, we can write N by V. N by V can be written as P upon RT. That RT goes to numerator. We can also write this lambda as RT upon root 2 pi sigma square Avogadro number into P. Right? Mean free path. Now what about collision frequency? Z. Collision frequency Z. What is it? Average velocity upon lambda. Collision frequency Z is nothing but average velocity upon lambda. A number of collisions. Lambda means distance traveled between collisions. Nu bar is velocity. Then number of collisions means from one collision to second collision. This is the distance traveled. Number of collisions happens per second. How you will calculate? Number of collisions per second. Lambda means from one collision to second collision. How much distance travel is called lambda. Right? So if lambda is 1, number of collisions are 1. right? Then total number of collisions possible is reciprocal of lambda. Na? If with one lambda we got one collision, right? Then number of collisions equal. Number of collisions equal to what you write? That's what I am writing, right? And the molecules are moving with certain velocity. Respond. Instead of lambda, if I substitute this term, what you will get? Root 2 pi sigma square nu bar into NV. We call this as ZA. Means only one molecule is moving, remaining all molecules are stationary. If all molecules are symmetrical and all molecules are moving, then I call it as ZAA. What do you mean by ZAB? Two different molecules make collision, then it is called ZAB. All we discussed this, man. States of matter chapter. Just a moment, I will open it. See this? Mean free path, lambda, distance traveled by molecule between two successive collisions. Right? What is lambda value? Lambda value. Root 2 pi sigma square, collision diameter, sigma RT into NV. Or we can write as RT upon root 2 pi sigma square NA into P. Correct? Then ZA is equal to what is ZA value? Root 2 pi sigma square average velocity into NV. Correct? Now, what is ZAA? 1 upon root 2. Observe, compare these two. What is it? Here it is root 2. This is 1 upon root 2. 1 upon root 2 pi sigma square average velocity into NV square. Now, ZAB. ZAB. This is root of 8 RT upon pi M. So, we wrote as 8 pi KT because outside pi is there. That also goes to numerator under the root. Then it becomes pi square. Now, the one pi got cancelled. So, root 2 8 pi KT by mu. What is this? Reduced mass. There are two different molecules, man. Average velocity formula, what is it? Root of 8 RT by pi M. This is nothing but average velocity. So this can be written as average velocity into pi. This is nothing but average velocity into pi into radius square NA into NB. Are you able to understand? Again, I am writing. If it is ZAA, what is the formula? Collision frequency if the same type of molecules are moving and are making collisions. So what is ZAA? 1 upon root 2 pi sigma square average velocity into NV square. Correct, sir? What is ZAB? NA, NB, RA plus RB square. Respond. Into pi into average velocity. Instead of average velocity, what I can write? 8 RT upon pi into reduced mass of AB. If I bring this pi under the root, pi square and one pi gets cancelled. So what you can write? You can write one more pi in the numerator. Correct? Whether we have taken same formula or not, check. Check whether this and that formula both are same or not. NA, NB, RA plus RB whole square into root of 8 pi RT upon mu AB. If it is one molecule, K. If it is one mole of molecules, R. Right? Say something, sir. Okay, wow. So that's why what we can write, if it is different molecules, two different molecules making collision, so we can write P into ZAB into e power minus EA by R. We can write that in this way. Arrhenius equation can be written in this form. Right? Respond. So either you can write this or simply write this one. Now take logarithm on both sides for this equation. What you will get? Ln k equal to ln A minus EA upon RT. At temperature T1, this becomes K1. At temperature T1, it becomes K1. Then what you will get? Ln K2 is equal to ln A minus EA upon RT2. Ln K1 equal to ln A minus EA upon RT1. Subtract both. Then what you will get? Ln K2 upon K1 equal to minus EA upon R into 1 upon T2 minus 1 upon T1. Respond, sir. Correct? If I plot a graph, if I plot a graph again between ln K versus 1 by T, how the graph is? Ln K versus 1 by T graph. Intercept is LNA, slope is negative. So the graph must be straight line with negative slope. Intercept ln A, slope minus EA upon R. Correct? Any questions in it? No. If it is in case of equilibrium reactions, in equilibrium reactions, means reversible reactions, then what I will write? Ln K forward equal to ln A minus EA forward by RT. Ln K backward equal to ln A minus EA backward upon RT. Say something. Correct or not? So then what you will get? Ln K equilibrium equal to K forward by K backward equal to. I am writing again. Listen. I am writing this as ln K. Don't write. There is one mistake. That's what I want to show. Ln K forward equal to ln A minus EA forward upon RT. Right? K backward equal to EA backward upon RT. Correct? Now I am subtracting both. What do you get? K forward by K backward is called K equilibrium. This gets cancelled. What do you got? Minus EA forward minus EA backward upon RT. Correct? EA forward minus EA backward is delta H. So ln K equilibrium equal to minus delta H upon RT. Correct? Response, sir. Any questions in it? No. Keep that aside. First come to back. In case of equilibrium reactions, we know delta G naught equal to minus RT ln K equilibrium. You know it or not? Correct? Delta G naught equal to minus RT ln K equilibrium. We know from thermodynamics. Yes or no? Right? Bring this RT to this side. What is ln K equilibrium equal to? Minus delta G naught upon RT. Here what you got? Minus delta H naught upon RT. We are getting two different equations now. Right? Delta G converted as delta H minus T delta S. If I write this as delta H minus T delta S, what do you get? Ln K equilibrium equal to minus delta H naught upon RT minus of minus plus T delta S. T gets cancelled. Delta S upon R. Now tell me this and this, which equation is more accurate? Which is more accurate? This one means kinetic theory of gases. Arrhenius equation has one limitation. It has not taken delta S term into consideration. Is it clear? Any questions? Right? Response, sir. Now one more thing. That's why in case of Arrhenius equation, to overcome that error, what I am going to do, observe this carefully. This is the equation. At temperature T1, can I write this K equilibrium as K equilibrium 1? If it is at temperature T2, then I will write this as K equilibrium 2. This is K equilibrium 2. So can write as Kp2. This as Kp1. Can I write it? Now I am subtracting both again. Ln Kp2 upon Kp1 equal to minus delta H naught upon R is taken common into 1 upon T2 minus 1 upon T1. Correct, sir? Correct? Now, here also I am doing the same. Ln Kp2 equal to minus delta H naught upon R T2 plus delta S naught upon R. Ln Kp1 is equal to minus delta H naught upon R T1 plus delta S naught upon R. Now I am subtracting both. What do you get? Ln Kp2 upon Kp1 equal to. Can I take delta H by R common in these two? So minus delta H naught upon R I am taking common into 1 by T2 minus 1 by T1. And what about these two terms? Gets cancelled. Now what I got? Are you able to understand? So actually there is an error in Arrhenius equation while I am calculating equilibrium constant. But if I apply temperature conditions also in it, what happens? Automatically that error vanishes. Is it clear? Are you able to understand? That's why don't take this ln equation directly. If you want to take that logarithm equation, you write that in this format. Right? If you want to involve this format also, then apply two different temperature conditions and follow it. If I apply two different conditions and if I follow it, what happens to that equation? Automatically it converts into this equation without any error, whether you follow thermodynamics or whether you follow Arrhenius equation. Is it clear? What we call this equation as Clausius-Clapeyron equation. This equation is called Clausius-Clapeyron equation. Clear, sir? Any questions in it? Are you able to understand what error is there in this equation? Clear, right? Right? So we are done with collision theory also. Same thing we have written in the notes. With some wordings, we have written that. Just I will show that and I will leave it. Collision theory I have not taken out. Here. This is done or not? See this collision theory now? For a reaction to occur, colliding molecules should possess sufficient energy and they do so in proper orientation to form products. Such collisions are called as fruitful or effective collisions. All collisions will not lead to product formation, right? They should possess minimum energy. That minimum energy is called threshold energy. What do you mean by threshold energy? Minimum energy required for reactant molecules to form products during effective collision. And proper orientation, we also call it as steric factor P, right? So this is the graph we have taken, or if it is the graph, what is this total energy called? Threshold energy. This energy gap is called energy of activation. That's why threshold energy equal to energy of activation plus already reactants having some energy, that energy. Clear? Any questions? Now, if a reaction occurs in forward as well as backward, this is energy of forward, this is activation energy for backward. Difference between these two is called delta H. So delta H of reaction equal to energy of activation for forward minus backward, right? If any reaction occurs in two steps, step 1, step 2, this middle gap is called, this is called intermediate. This and this are called as activated complex 1, activated complex 2. Now, if you see this, which is a slow step? If energy of activation is more slow, so which is slow step? First step. Slow step is rate determining step. That's why first step is written as slow step or rate determining step. Any questions? Same thing we have written according to Arrhenius. Respond. Same thing only now. Here I missed a few more points. What is it? ZAA. Two equations I have not written. What are they? ZAA equation and ZBB equation. What is ZAA? Just now we have seen, man. What is ZAA? 1 upon root 2 pi sigma square average velocity NV square. Correct? Huh? What is ZAB? NA, NB, RA plus RB whole square. Root of pi also I brought inside. 8 pi RT upon mu of AB. Correct, sir? Same thing only, na? No. This graph also we have seen. We have seen this graph or not? Take logarithm on both sides. Again, plot a graph. Just a moment. It's taking time to load. Same thing or not? Now, at temperature T1, at temperature T2. In case of reversible reactions, equilibrium reactions, we should not write ln k equilibrium equal to minus delta H by RT. We need to write as delta G by RT. But when you are taking equilibrium's ratio with respect to temperature, then automatically it converts into delta H by R. Is it clear? Any questions? Respond. Same thing I have written. Right? What is the effect of catalyst? That also we have written. Complex reactions already we have done. Parallel, consecutive, opposing. Done or not? Nuclear chemistry already done. So we are end with this chapter. Right? Now, in addition to that, in physics, you will learn few more terms. Binding energy per nucleon. Right? Binding energy per nucleon, N by P ratio. These three terms you will learn. Right? What do you mean by binding energy? Binding energy, or in nuclear chemistry, man, what do you mean by binding energy? Energy required to hold all the nucleons together is called binding energy. Just let me show that. Series. Binding energy is nothing but energy required to hold all the nucleons together. Inside nucleus, when all nucleons are present, some part of this their mass converts into energy, and that energy holds them together. Right? So that difference is mass is called as mass defect. This is binding energy equal to delta mc square. Nothing but Einstein's equation, where delta m is nothing but called as mass defect. What do you mean by this mass defect means? What is the mass of nucleons minus how much mass converted into, some mass is converted into energy, na? So mass of nucleons minus what is the actual mass now? So we write sum of masses of protons plus masses of neutrons. Add all masses of protons and mass of neutrons. Minus mass number. Then I will get mass defect. Mass of protons plus mass of neutrons minus mass number. The difference is called mass defect. That into c square gives binding energy. Right? If mass defect is 1 AMU, right, that 1 AMU into c square gives binding energy. Approximately you will get 931.5 mega electron volts or million electron volts. If mass defect is, if I divide that binding energy value with mass number, then you will get binding energy per nucleon. If binding energy per nucleon value is high, then that nucleus is stable. If you plot a graph, that graph looks like this. If you plot a graph, you will get a graph somewhere like this. Binding energy per nucleon versus mass number graph. Right? So this is somewhere for mass number for close to iron, cobalt, nickel. For those regions, you will get higher binding energy. So among all nucleus, which is more stable nucleus means we will say iron theoretically, but practically it is nickel. Now, one more term is there, packing fraction. Packing fraction means mass number mass of nucleus minus mass number upon mass number into 10 power 4. This is called packing fraction. Here also, if you plot a graph, you will get a graph reciprocal to it. So for few values, you will get negative. For few values, you will get positive, right? If this packing fraction is lowest, then it is more stable. You will find this packing fraction lowest for iron, right? So this is binding energy per nucleon, packing fraction. Then another term is there called N/P ratio. If you plot a graph between number of neutrons versus number of protons, I am taking number of neutrons on y-axis, number of protons on x-axis for different nuclei, right? You will get different dots for different atoms. If you observe them, most of this fall in one region. Most of those dots fall in this region. We call this region as zone of stability. Few nucleus positions, neutron to proton ratio for few nucleus fall in this zone or here or here. Whichever fall in this zone, they are unstable. Such nucleus are unstable due to excess of neutrons. Few fall in this zone, few fall in this zone. So all these three zones are unstable zones. Nucleus which fall in this zone, they always emit alpha particles. Which fall in this zone, they emit beta particles. Which fall in this zone, they will either emit positrons or they will do k electron capture. Right? This is the reason why unstable nucleus shows radioactivity. We are discussing now. Radioactivity means unstable nucleus converts into stable nucleus by emitting particles. Why they are emitting particles means because they are fall in these unstable zones. If they fall here, they will do alpha emission. If they fall here, beta emission. If they fall here, positron emission or K electron capture. That's all. Same thing we have written in one note, in one order. Same explanation. Just a moment. Let me close this. It's taking time to load. Let me open the PDF form. See this? It is not, it is there in your packages in additional information, right? See this? These things already we discussed or not? Radioactivity, artificial radioactivity, natural decay, 4n, 4n plus 1, 4n plus 2, 4n plus 3. Already we discussed this, right? Now, artificial decay examples also we have seen. This is properties of alpha, beta, gamma radiations. Now see here. Nuclear stability. Why a nucleus is stable or unstable? To explain that, we have different theories. One concept was binding energy. What it says, some part of mass of nucleus was converted into energy. That energy will hold nucleons together. So energy required to hold nucleons together is called binding energy. How to calculate it? Is equal to delta M into C square. What is delta M? Mass defect. Mass of all nucleons minus mass number. That is mass defect into C square. Now binding energy per nucleon. Whatever binding energy you calculated here, divided by mass number used, binding energy per nucleon. If you plot a graph between binding energy per nucleon versus mass number, you will get, observe this curve. So binding energy nucleon per nucleon is maximum for iron. So iron is more stable nucleus according to binding energy per nucleon graph. Same way packing fraction. What is packing fraction? Isotopic mass minus A upon A into 10 power 4. Here if you plot a graph, you will get a graph in this way. Whichever is having lower packing fraction, they are more stable. So for iron, cobalt, nickel values are low. So packing fraction is lowest for iron. Binding energy per nucleon is highest for nickel. So according to binding energy per nucleon, nickel is more stable. According to packing fraction, iron is more stable. Next concept, N by P ratio. If you plot a graph between neutrons to protons, right, you will get different dots, right? We call this, which fall in this region, we call it a zone of stability. If you find any nucleus other than that, they are all unstable. If you find any nucleus position here, right, that means unstable due to more number of neutrons. They always emit beta particles. So beta emission occurs. Clear or not? If it falls in this region, alpha emission. If it falls in this region, K electron capture or positron emission. Means all these are below this region. Means they are unstable because of excess of protons. If they are present here, they are unstable because of excess of neutrons. That's what we have taken. Unstable due to excess of neutrons. Unstable due to excess of protons. Right? Alpha emission, positron emission, K electron capture. Now, Rutherford, he has studied all stable nucleus and unstable nucleus present, right, among all elements and their isotopes. What he observed is most of the nucleus having even number of protons, even number of neutrons. Very few nucleus have odd number of protons and odd number of neutrons. What he observed is only 5 nucleus is having both odd in number. Those are deuterium, lithium, boron, nitrogen, tantalum. These are 5 nucleus which are stable possess odd number of protons and odd number of neutrons. And he observed all those numbers and he predicted some magic numbers. Nucleus having either 2, 8, 20, 28, 50, 82. Number of protons or number of neutrons. They are found to be extremely stable. And hence those numbers are called as magic numbers. Right? Forget about these. These numbers are common in both. No? So that's why we call them as magic numbers. 2, 8, 20, 28, 50, 82. These are called as magic numbers. Clear? Already we know this one. Rate of nuclear decay. You studied these things or not? Right? Now types of nuclear reactions. Types of nuclear reaction. Projectile capture means when you throw one particle, nucleus will capture it. Then it is called projectile capture. See this uranium 92-238 is capturing neutron and converts into uranium 239. It is not giving any other particle. Only radiation is giving, but not any other particle. Then it is called projectile capture method. Next, particle means when one nucleus is bombarded with one particle, it converts into another nucleus by emitting another particle. Then it is called particle. Any questions in that? Next, spallation reactions. If one nucleus is bombarded with one particle, it breaks down to many particles. Then it is called spallation reaction. Next, fission reactions. Fission reactions means when a heavier nucleus is bombarded, then it forms two moderate size nucleus by emitting some energy and neutrons. Then it is called nuclear fission. So you got barium 141, krypton 92 plus 3 neutrons plus 200 mega electron volts energy. Nuclear fusion reactions. Lighter nuclei will fuse to form relatively heavier nuclei by emitting energy. Now, if you calculate what is the energy emitted per nucleon, then efficiency will be high for fusion reactions than fission reactions. Right? Uses of radioactivity. Sodium 24 for blood circulation, phosphorus 33 for brain tumors, iodine 132 for treatment of thyroid, cobalt 60 for treatment of cancer, and so on. Already we have seen these two equations or not? To find age of rocks, to find carbon dating technique, to find age of fossils. Done or not? Right? So that ends this chapter. Right? These are all theory. Whatever we discussed today, all these are theory based. So that's why I just quickly completed it. Right, sir. We will solve few questions and then I will go to next chapter in next session. Open your target booklets. Whose book is this? Star mark questions we will solve. Shall we solve star mark questions? Yes, sir. Yes, sir. They have not given any star mark questions in it. Oh, okay. Can you solve this one? For an elementary chemical reaction, A2 gives rise to form 2A, the expression dA by dt is. How to solve this? Solve this. Online, anyone there or not? There.
Yes, sir.
Solve this, man. What you'll write first? Instantaneous rate formula. What you'll write? What you'll write? Minus dA2 by dt is equal to 1 by 2 dA by dt. This is the instantaneous rate if the reaction is given as A2 gives rise to 2A. Correct? Correct or not? According to law of mass action, what you will write? K1 into A2. Respond. Correct? This is for A2 gives rise to 2A reaction. If it is 2A gives rise to A2 reaction, then what you will write? Same instantaneous rate equal to. What you will write now? 1 by 2 minus dA by dt, correct? Is equal to dA2 by dt. Respond is equal to, according to law of mass action, K minus 1 into A square. Respond, sir. Anything? Now what they want? They want everything in terms of dA by dt only. Now what I can write dA by dt here? dA by dt equal to, what you write? 2 K1 into A2. Here dA by dt can be written as minus 2 K minus 1 into A square. Respond, sir. Correct or not? So sum of this is the overall rate expression for it. This is dA by dt only for this. This is the dA by dt only for this. If both are involved, I need to add both or not. Correct? So 2K1A2 minus 2K minus 1 into A square. What is the answer for it now? Second option. Check. Yes or no? Right? Will you answer? Will you ask any other questions? Directly it went up to 50. 64, right? So A to P1, A to B to P2, C to P3, D to P4. The order of above reactions are A, B, C, and D respectively. The following graphs are obtained when log rate versus log concentration are plotted. Log rate versus log concentration. Generally, what we will write? Rate is equal to rate constant K into concentration of AT power n, nth order reaction. Response, sir. Correct or not? Now, log of R is equal to what you will write? Log K plus n log AT. Correct? Now, if you plot a graph between, if you plot a graph between log R versus log R versus log of AT. What you will get? How the graph will be? Slope is positive. Intercept also positive. Response, sir. So what is this intercept? Log K and slope equal to n. Right? As n value increases, slope of the curve increases. Correct or not? Now observe all these graphs. Which is having highest slope? D. Means order of D is maximum. So D greater than, B greater than, A greater than C. Response. Correct? Say something, man. So D greater than, B greater than, A greater than C. Instead of that, if they ask rate constants, what do you write? No, we will check this as rate constant K, na? Intercepts we will check. Which is having highest intercept? C greater than, A greater than, D and B same. Correct, sir? Log K of C is greater than log K of A, na? A. D and B is approximately same, na? Both are from same point. Correct? Intercept represents log K. Any questions? Next question, sir. 68, right, 68. Right? A bacterial infection. Or infection means bacteria will grow or bacteria will decrease. Grow means bacterial multiplication reaction. Already we have seen that equation or not for bacterial multiplication. Right? We will not write minus a dn by dt. We will write it as plus a dn by dt. Response, sir. In a rate of reaction, concentration of A is decreasing. That's why you write as minus dA by dt. Here bacteria concentration keep on increasing. So you write plus a dA by dt. Correct? Response, sir. So Nt equal to N naught into E power T. In an internal wound grows as Nt equal to N naught into E power T. Exponential T. Where T, time T is in hours. A dose of antibiotic is taken orally. It needs 1 hour to reach the wound. Means up to 1 hour, it will not reach the wound. Means after until 1 hour, it grows. Now, once it reaches the wound, bacterial population grows down to dn by dt equal to minus 5n square. Means what happened to rate? Decreasing. dn by dt is negative now. So rate of bacteria is decreasing. What will be the graph for n naught by n versus a time? What happens? Up to 1 hour, bacteria grows na. N naught is initial number. Nt is final number. N naught is initial number of bacteria. Nt is final number of bacteria. Right? Up to 1 hour time, bacteria keep on growing on constantly in a first order kinetics. It is in the form of Nt equal to N naught into E power something means it is in the form of first order kinetics or not? Respond. So NT value keep on increasing. Means what about N0 by NT value? Decreasing. This is N0 by NT. Correct? I say something, sir. Right? So what we can write N0 by NT can be written as e power minus t up to 1 hour. Up to 1 hour means I have to write as e power minus 1. I say something. Up to 1 hour. It will take 1 hour time to reach it. So what happens to this value? Up to 1 hour. It changes up to what is N0 by NT at 1 hour equal to 1 by E. Right? When it reaches from 0 to 1 hour. Initially time is 0. NT equal to N0 when T equal to 0. Right. When T equal to 1 hour, what is NT equal to? N0 into e power minus 1. Correct, sir? Correct or not? Now, here, what is NT by N0 equal to? 1. Correct? Now, what is NT by N0 equal to? 1 by E. E is 2 point something, right? E value, man. 2 point something. So, it should change from 1 to 1 upon 2 point something means it is decreasing or not? So, up to 1 hour, it decreases. Right? After that, what happens? Rate is decreasing, means NT value decreases. NT value decreases exponentially. Correct? NT value decreases exponentially means what happens to NT by N0 value? Increases exponentially. So first it decreases and then increases exponentially. So which is the graph? First graph. Response, sir. Correct or not? Are you checking the answers? Checking the answers or not? Next question. Next question, sir. Second option. 68. Hey. Oh. Graph after 1 hour. See the question. They are not asking N0 by N graph. N0 by N versus T graph after 1 hour. Right? Up to 1 hour, they don't want. Up to 1 hour, it decreases. After that 1 hour, integrates. Means they want after this point only. Are you able to understand what they are asking? They're asking graph after 1 hour. Means after this point only they are asking. After that point, what happened? It increases, na? Correct or not? So therefore, answer became 2. If they have not given this after 1 hour term, what is N0 by N versus T graph? First graph. N0 by N versus T graph is first graph. N0 by N versus T after 1 hour graph is second graph. Is it clear? Any questions, sir? Understood or not? Right. Next. Next question, sir. Next question, sir. The star mark questions are very less here. 79. Consider the following plots of rate constants versus 1 by T for 4 different reactions. Which of the following orders is correct for the activation energies of the reactants? Rate constant versus a T and they want activation energy. Means can I say K equal to A e power minus EA by RT, correct? Take logarithm. Log K equal to, first I will take ln k equal to ln A minus EA by RT. Correct? This ln k can be written as 2.303 into log k. So 2.303 into log k equal to 2.303 into log A. I brought that 2.303 to this side. So EA upon 2.303 R into 1 by T. Correct, sir? Respond, sir. Now if you plot a graph, how the graph will be? So I am plotting graph between ln k versus 1 by T. Log k versus 1 by T. How the graph is? Slope negative, intercept positive. Intercept positive, slope negative means, can I write graph will be like this? This is log A and slope equal to minus EA upon 2.303 R. Correct? If EA value is high, slope will be more negative. Now, which is having more negative slope? C. Which is having a less slope? B. So EA value of B is lowest. So EB must be lowest and C must be highest. So answer is option 2. Correct, sir? Next question. 86 and 87 also. 83 also. Solve 86. Both ACs are not working. You switch it off or not working. Solve that question number 8. Solve. For a chemical reaction A to B, it was found that concentration of B is increased by 0.2 mole per liter in 30 minutes. Average rate. What is average rate? Total change in concentration by total change in time. Over. So answer 0.2 divided by 30. Respond, sir. So average rate equal to 0.2 molar divided by 30. But they want answer in hours. Means, can I write that as 1 by 2? Hours, man. So what is this value? 0.4 mole per liter per hour. So answer is 4. Waste question. 87. That's why I'm writing it as 4 into 10 power minus. Gamma 1A plus gamma 2B gives rise to gamma 3C plus gamma 4D. Concentration of C changes from 10 millimole per liter to 20 millimole per liter in 10 seconds. Rate of appearance of D is 1.5 times the rate of disappearance of B, which is twice the rate of disappearance of A. The rate of appearance of D has been experimentally determined to be 9 millimole per per liter per second. Therefore, rate of reaction is. Sorry. Concentration of C changes from 10 to 20 in 10 seconds. What do you write? Can I write rate of reaction in this way? Rate of reaction equal to 1 upon gamma 1 into minus dA by dt. Can I write it? Is equal to 1 upon gamma 2 into minus dB by dt. Correct? Is equal to 1 upon gamma 3 into dC by dt is equal to 1 upon gamma 4 into dD by dt. This is rate of reaction. What they give? Rate of appearance of D. Rate of appearance of D means dD by dt. Correct? This is appearance of D. dD by dt is 1.5 times of 1.5 times of rate of disappearance of B. Correct, sir? Which is twice the rate of disappearance of A. Means they are talking about B or D? 1.5 times of rate of disappearance of B, which is means they are talking about B. Response, sir, means minus dB by dt equal to minus dB by dt is equal to 2 times of minus dA by dt. Correct, sir? Then rate of appearance of D has been experimentally determined to be, they gave this value as 9 millimole per liter per second. One more. Concentration of C changes from 10 to 20 in 10 seconds. Concentration of C changes from means dC by dt. Given dC by dt equal to concentration of C changes from dC by dt equal to what they give? 10 to 20 means change is 10 in 10 seconds. Means 1 correct millimole per liter per second. Now you want rate. What is rate of rate? Simply observe this. Bring this 3 to this side. Simply bring this 3 to this side. What do you get? 1 by 3 dD by dt is equal to 1 by 2 minus dB by dt. Correct, sir? Is equal to, bring this 2 to this side. Bring this 2 to this side, man. 1 by 2 d minus dB by dt is equal to minus dA by dt. Correct? Say something. Right? Correct or not? Now, dD by dt is 9. Then 1 by 3 dD by dt is 3. Correct, sir? So all of them is equal to 3 millimole per liter per second. Response, sir. Correct, sir? Now check carefully. dC by dt already they gave. They want rate. What is rate? 3, yeah? Check the answer. I don't know. Check the answer.
Given one. Given one.
The answer is given as 1. Means something. What is it then? They have not given it as 3. They gave answer as 1. Means something wrong. What it? Why? Maybe. What, sir? What we mean by rate of the reaction? Change in concentration by change in time. Correct? In the total thing, in the first statement itself, they told. Read it carefully. Remaining all is nonsense only, na? And remaining total thing is nonsense. Already in the first statement itself, they gave what is rate. Read carefully. What they said. Concentration of C changes from 10 to 20 in 10 seconds. Means what is rate? Already we counted, calculated 1 millimole per liter per second. Over. Remaining all is nonsense only. Now, who cares about all these relations? They are asking rate. Over. They already gave in the first statement itself. Say something, man. Who cares about all this nonsense? Right? Means, observe this. This is nothing but rate. If they ask you gamma 1, gamma 2, gamma 3, gamma 4 also we can solve. Right? This is nothing but 1 upon gamma 3 into dC by dt. Means gamma 3 equal to. Let's say something. Gamma 3 is nothing but 1. If a gamma 3 is 1, remaining all. This is over. Now, rate is 1. Rate is 1 means can I divide all of them with 3? So 1 by 9 into dd by dt is equal to 1 by 6 into minus dv by dt is equal to 1 by 3 into minus dA by dt. Response, sir, is equal to 1 by 1 into dc by dt is equal to 1 millimole per liter per second. Respond. Are say something, sir. What is this term? Gamma 4. This term. Gamma 2. This term. Gamma 1. This term. Gamma 3. Say something. What is gamma 1 is to, gamma 2 is to, gamma 3 is to, gamma 4. 3 is to, 6 is to, 1 is to, 9. So reaction also I will write as 3a plus 6b gives rise to C plus 9d. In the first statement itself, they told about rate of reaction. Change in concentration of C is a 10 to 20, means 10. Change in time is given as already 10, means rate of reaction already over. Here itself it is over, rate of reaction. Here itself rate of reaction is over. Correct? Then who cares about remaining all nonsense, man? They might have given a little more tough. Instead of asking rate, they might have asked what is gamma 1 is to, gamma 2 is to, gamma 3 is to, gamma 4. Then question is start. Right? Say something. Clear? Understood? Next question, sir. $80. You ask for something. Girl, you are not asking anything, huh? You told 83 something. 92, sir. Half-life for the decomposition of a sample of gaseous compound initially at 55.5 kilopascal was 340 seconds. Then the pressure was 27.8 kilopascal. Half-life was found to be 170 seconds. Order of reaction. When concentration, when pressure is changing, half-life also changing. Definitely is not first order. Reason.
Independent.
Independent of concentration, na? First order is independent of concentration. So definitely it is not first order. We know T half is proportional to 1 upon a power n minus 1. T half equation, man. What is T half equation? 2 power n minus 1 upon k T n minus 1 into a power n minus 1. Correct? Nth order reaction, man. T half equation for nth order reaction, correct? So T half is proportional to 1 upon a power n minus 1 or not? So what I can write now? T half 2 upon T half 1 is equal to A1 upon A2 whole power n minus 1. Accepted? What is T half 2? 170. T half 1, 340 is equal to what is A1? 55.5. What is A2? 27.8 whole power n minus 1. So this is how many times? 2 times. This is how many times? 2 times. Correct? So 2 power minus 1 equal to 2 power n minus 1. Means n minus 1 equal to minus 1. Means n equal to 0. So it is following 0th order kinetics. Check the answer. Correct or not? Yes or no? I think you need to study a little more. Better I will stop today's discussion here. At least by coming, when you are coming to next class, read the theory, try to solve some questions, ask doubts. One lecture I will dedicate for numerical solving. Next lecture I will go for P block chapter, right? P block chapter mostly theory part. Few topics require explanation. Those topics I will explain. The remaining theory I will rush, right? Online students, are you following or not?
Following.
Yes, sir.
Following.
Vinodar, Sai Visagan, Ritika, Loga Prasanna, Janita, Vasumati, Jivitradit, Afa.
Yes, sir.
Present, sir.
Present, Sarah. Huh? Are you listening to classes properly or not?
Yes, sir. Listening, sir.
Padma Vinita, Kirti Sri,
Yes, sir.
Yalini, Nachatra.
Present, sir.
Right, sir. Online students, you can leave. I will download your attendance and I will give your attendance. You can leave. Bye, sir.
Thank you, sir.
Thank you.